Example 3 is a problem from chapter 18 in the book that deals with thermodynamics of redox reactions. And the problem asks us to calculate the standard free energy change for the following reaction at 25 degrees Celsius. Here we have our reaction, and all we need to solve for the standard free energy change is first to find the standard EMF, which is given by this equation right here. And once we find the E cell, we can plug it into our standard free energy change equation. And also we have some half reactions we use to find the cathode and the anode for the standard EMF. So to save time, I've already written out the half reactions for this reaction right here. And we see that AU is actually reversed from the half reaction right here. So instead of gaining electrons, it is losing electrons, causing this to be oxidized and thus our anode. For calcium, we see that compared to its half reaction, it is still gaining electrons, and this is the behavior of a reduction, thus this is our cathode. Now that we have identified the anode and the cathode, we can plug it into our standard EMF equation, which I already have written out right here. So our cathode is, we have from this number right here, which is, for calcium, negative 2.87 volts. And since the equation for AU is switched, we will switch the signs for the volt. So instead of positive 1.5, it'll be minus 1.5 volts. When we plug this into the calculator, we get a standard EMF of negative 4.37 volts. Now once we have this, we can solve for our standard free energy change. So we'll have delta G, rewrite the equation here, equal to negative N times F of the E cell. So our N we get from our electrons, and we see that in both half reactions 6 electrons are being transferred, so our N will be 6 times Faraday's constant, which is always 96,500 joules per volts times moles, times our standard EMF value, which is negative 4.37 volts. Now all we have to do is multiply these in the calculator, and we get 2.53 times 10 to the negative 3 kilojoules per mole. And this is our standard free energy change for this reaction.